content objective 2, or computing secant slopes and then estimating tangent slopes when we are given an explicit function. So what we want to do is we want to be able to write down the process that we'll use to estimate tangent slopes when we're given an explicit function, because in the world of calculus you'll have 4 different types of problems. You'll be given things analytically, which is like a function, algebraically. You can be given things in a table of data. You can be given things verbally, like in a story problem, or you can be given functions or information about a problem graphically. So in this particular content objective, we're working with explicit functions. So this is an analytical or algebraic application of this whole concept of tangent and velocity. So first we'll connect to our old knowledge. You all remember this word slope, and the word slope, pen will work. The word slope, if you recall, was a rise over a run. That was probably how it was first taught to you. So with rise over run, the rise is a vertical change, so that would be a change in your y coordinates, whereas the run is a horizontal change, which is the change in your x coordinates. So graphically, if we have 2 points, a f of a and b f of b, we can talk about the slope between those 2 points by looking at the rise, which is the change in the y coordinates, or y coordinate f of b minus the y coordinate f of a. That goes on top here. And then we'll divide by the run, which is the change in the x coordinates, which would be b minus a. So in example 1, we're given one of our points, which is 2 ln of 2. So we'd be looking at a log natural graph, and we'd have a point 2 ln of 2. And then we're going to create another point q, and then use our calculator to find the slope of the secant line. So in this particular one, part A, we have a point q that has an x coordinate of 1.5. So if I want to set up my slope, I would do the y coordinate minus the y coordinate over the x coordinate minus the x coordinate. So what we could write down here is the slope of PQ will be our y coordinate that goes with 2 minus our y coordinate that goes with 1.5 divided by our x coordinate of 2 minus our x coordinate of 1.5. By the same token, we can move to part B of this and see that we want to get even closer. So instead of being at 1.55, we want to be at 1.999. So now we're getting even closer, and we can write the slope this time will be f of 2 minus f of 1.999 divided by 2 minus 1.999. So we have set these up. What we want to do now is connect it to the calculator, because it says we want to use your calculator to find the slope. So we're going to go access our calculator. If you look at your calculator, we'll turn it on. Some of you may have a screen that looks like this. What we want to do is clear out this entry panel. We don't really care what's up here in the main part of the screen, but this particular panel right here, this strip, is where we're always going to put new information. We also want to be able to put this curve into our calculator so that we can use it. And the best place to put this is where you also put it in your TI-84s, which was in your Y editor. Now if you remember, on your TI-84s or 83 calculators, whichever you had, you used to have a button right here that said Y equals. Well, it turns out we have that same Y equals buried. It's in the upper right hand corner. You see a little color that matches your diamond key. So to access that old Y editor, we're going to hit diamond and F1. Now some of you, before I go there, some of you did not have this screen when you started. You have a bunch of pictures that look like applications. So to get to this picture, you need to hit home, and then if you hit diamond Y equals, you can get to that same Y editor we're accustomed to having. So we'll arrow up. If there's something saved in here because you have a library calculator, just clear out what's ever there. And now in Y1, we want to store this function f of x equals ln of x. So if you recall, your ln was in this column, and it's the same place in this particular calculator. We just access it using our second button. So we'll do second enter. Notice that we have an opening parenthesis. So what's critical on the 89 is that every parenthesis you open, you must also close, or you will get a syntax error. So now we've got our y1 equals ln of x. What's really nice about the TI-89 is now that we have this stored in y1, anytime we type y1, we will be accessing this. So go to your home screen, and what we're going to want to do is we're going to want to enter y1 of 2 minus y1 of 1.5, and then we'll divide by 2 minus 1.5. Same thing here, we'll have y1 of 2 minus y1 of 1.999, and we will divide by 2 minus 1.999. So in our calculator, we can remember that fraction bars are grouping symbols in disguise, so we'll insert a parenthesis for the top of our fraction, and we simply type y1 of 2 minus y1 of 1.5, close y1, close the top, then we'll divide, open the bottom, 2 minus 1.5, close the bottom, and then hit enter. Notice we got 0.575 as our approximate slope, or our secant slope, when the points were 2 f of 2 and 1.5 f of 1.5. So now if we want to compute this one, what's nice about the 89 is that we can delete and just enter in the 1.999. When you hit enter, this entry panel here will retain whatever you had in there before. So if it's something you want to use, you don't have to do that second answer or second enter like you did on your 84s. It's already there. So now again, we'll hit enter, and we see here that we're at 0.5001. So back on our notes, we can see that this one was 0.575 and this one was 0.5001. Notice that we're setting the stage for that whole concept of limit of tangent lines, or excuse me, limit of secant lines creating a tangent line, because we fixed the point 2 f of 2, and then we're letting the x-coordinate of the second point q get closer and closer to 2. So if we want to use our calculator to estimate the tangent slope at point P, our goal is to get 2 points that are super close together. We cannot use the same point, because if I had the exact same point, then I'd be doing b minus b, which would give me a 0 on the bottom, and that is not allowed. But I can get really close so that those two secant points are getting awfully close to each other. The tangent slope by choosing 2 points that are very close together. And since I'm interested in the tangent slope at 2, I'm going to use f of 2 as the point that is stuck, and then I'm going to let the x-coordinate of my second point be really close. Now we were already at 1.999, so I'm just going to go another couple of 9s out. So I'm getting nice and close. And then I can bring up the calculator to compute that. Notice again I've got that same thing that I already entered, so all I need to do is enter more 9s. And we see we're getting awfully close to a half. So over here we could say that tangent slope is a half. So now what I'd like you to do is try your notes web exam problems. There are 2 of them. Don't do them online yet, and then write out the process in words that you would use to estimate tangent slopes when you're given an explicit function.